Page 127. Rational exponents.
Y'all gotta get that confident, huh? Thank you.
You can write a radical expression in an equivalent form using a fractional in parentheses rational, because that's what rational is basically. It's when it's completely reduced, you still have a fraction. We call that a rational expression. Exponent instead of a radical sign.
Complicated.
Not really. So before I show you how to do problems that have rational exponents, we need to know how to convert a term that has a rational exponent to a radical and a radical to a rational exponent. 'Cause this is going to help us solve the equations. The equations are really similar to the ones that we just did on 125 and 126. These are still called radical equations, even if you don't see a radical, okay? If your exponent is a fraction, we can change that. If the base of the exponent has a variable in it, and the exponent's a fraction, we can convert that to a radical, right? So that's a radical equation. So even though it doesn't look like a radical equation to begin with, it still may be a radical equation if that variable is raised to a rational exponent. All right, so that's why we're still in the radical section. Okay, so first of all, if I had the square root of 36, we know that's 6, but we're not simplifying it. I just want to rewrite it in an exponential form, okay? So the square root of 36 is the same thing as 36 raised to the 1/2. What you said?
That looks
Let me show you. What's the index here?
It's an index.
Yeah. What's in the elbow? What root am I taking?
The-
Square root. Right? Notice there's a 2 right here.
Why is it necessary?
That comes from the index. What is 36's exponent?
1.
1. Notice there's an exponent of 1, or 1 is in the exponent, it's the numerator. So 36 to the 1/2 means the same thing as the square root of 36. If I said, hey, simplify 49 raised to the 1/2, what would you say?
7.
7. Means the same thing, right? If I said convert it to a radical, you'd say square root of 49. But if I said what is 49 raised to the 1/2? 7. Means the same thing. So how I remember what goes where is I know that anything raised to the 1/2 is the square root of the number, right? So I know what goes where there. So if 36 was being raised to the 1/2, I know the index has to be the denominator, and then the exponent has to be the numerator. So on anything like this, I just think about one that I know for sure, and that helps me remember what goes in what spot. You know what I mean? Okay, so the cubed root of 64, what would that be?
8.
I don't want to simplify it. I just want to write it as an exponential form. It would be what? 64 to the 1/3. So that's called exponential form. The directions on your homework call it exponential form, so. How about the fourth root of 5 cubed? Again, I'm not simplifying, I'm just rewriting it in exponential form. What would that be?
To the third fourth.
5 to the 3/4. How about the fourth root of 16? 16 raised to the 1/4 power. How about the square root of x cubed? X raised to the
Third.
3
Over 1, 6.
halves. Index is 2,
Oh.
right? So, and we don't say 3 twos, we say 3 halves, right? So x raised to the 3 halves. Do you think we could go the opposite way?
Yeah.
Okay, so let's convert exponential form to radical form. Example, x raised to the 3/7 power. That's exponential form. In radical form, it would be what? Okay? The 7th root of x cubed. How about x raised to the 1/6 power? 6th root of x. Is it necessary to put the 6th root of x to the first power? No. If I did, is it okay? It's not wrong, but it's implied. We don't need to. We're past that. What about x raised to the 2/7? The 7th root of x squared. Boom. How about x raised to the 1.5? Ay, ay, ay. Is that a fraction?
It can be.
So is a 1 maybe going to be an exponent and a 5 an index?
No.
No. No. Could I turn that into a fraction?
Yeah.
Okay, let's do that over here on the side. 1.5, isn't that the same thing as 1 and 5/10?
Or 1
Which is the same thing as 1 and 1/2. Can we leave it as a mixed number and figure out what the radical is? No, we need to make it improper, right? So remember to do that. 2 times 1 is 2, plus 1, the numerator is, and the denominator of the fraction stays the same. So x raised to the 1.5 is the same thing as x raised to the 3/2. Am I right? Okay. Now can we turn it into a radical? What would it be? Square root of x cubed. What if I had the 4th root in parentheses 5ab close parentheses, and the quantity is being raised to the 3rd power?
4 to 3.
3/4.
So like this. Right, I would need parentheses around the 5ab because 5 is being raised to the 3/4 power, A is being raised to the 3/4 power, and B is being raised to the 3/4 power. So the parentheses are very important. If you don't have them, if we didn't have the parentheses, only B would be raised to the 3/4 power. Which leads me to a problem such as this. If I had the cubed root of 5x squared, is that 5x quantity raised to the 2/3?
Yeah.
Does 5 have an exponent of 2?
No.
5 has an exponent of what?
One.
1. Isn't that the same thing as 3 times 5 to the first times x squared?
Yeah.
Not that we would have to write it that way, but that's a product. 5 doesn't have an exponent of 2, it has an exponent of 1. So if we turn that into a radical, 5 would be being raised to the 1/3 power, while x is being raised to the 2/3 power. And there's nothing else I can do with that. They just have different exponents. It would only be the same if that whole product was in parentheses, and then obviously you need to make sure that it stays in parentheses when you bring that exponent out. Here, parentheses make all the difference in the world. I've been trying to tell you all that for years. Okay? Alright, so that's important to know before we can solve some of these other radical equations. They are pretty radical, don't you think? Some may say rad.
Far out.
Toads my goats.
Yeah, bro.
Let's solve 3 open parentheses x plus 1 quantity raised to the 2/3 power equals 12. Now this is what I was talking about. It says solving other radical equations. Do you see a radical here? No. To be a radical equation, you have to have a variable under a radical. I don't even see a radical. So why am I calling it a radical equation?
Rational exponent.
Oh, we got to go through.
The rational exponent means that I could turn x plus 1 into a radical, and the radicand would have a variable in it, right? So even though you don't see a radical there, we can turn it into a radical equation because of that fractional exponent, and there would be a variable in the radicand. Okay? Cool beans? So, we're still, when we have parentheses, we don't have a radical yet. We need to isolate those parentheses just like we isolated a radical, if not already. So, are the parentheses isolated? No, how can we isolate them?
Divide by 3.
You know it. So 3 times x plus 1 quantity raised to the 2/3, that's currently one term. So I divide that whole term by 3, and then I divide 12 by 3. So on the left side, I'm left with x plus 1 quantity raised to the 2/3 power equals 4. Now probably you're wanting to turn the left side into a radical. If you do that though, you're going to see that you're going to say, okay, I don't know what to do now. Don't do that. Don't do that yet, okay? We have to remember the power to a power rule. When you have an exponent, and that exponent has an exponent, that's called power to a power rule. Do you remember what you do with those exponents? You multiply them. Power to a power rule says keep the base, multiply the exponents. Okay? If you had 5 raised to the 1/3, and you multiply, let's do 5 raised to the 2/3, and that was raised to the 3/2, that means I keep the base, multiply the exponents, right? And we just reviewed on how to multiply fractions. Numerator times numerator, denominator times denominator. What's 6 divided by 6?
More.
What's 5 to the first?
More. I mean, not more. 5.
5. So those were the reciprocal of each other, right? So if I multiplied my exponent by if I raised my exponent to the reciprocal, in the end, it got rid of the exponents and just left me with my base. The reason I show you that is I'm trying to solve for x. Can I just subtract 1 from both sides? I can't do anything until I get rid of that exponent. So if I were to raise that exponent, power to a power, up to its reciprocal, in the end, that would get rid of the exponent, right? But I can't just do that to one side. If I raise the left side of my equation up to the 3/2 power, then you guessed it, I have to raise the right side up to the 3/2 power. Equations, we keep balance, right? Just like in your lives. Let's write it little ditty. Raise both sides of the equation to the reciprocal of the exponent. So just like I showed you in my little example on the side, I did 2/3 raised to the 3/2, which was 6/6, which is 1, right? So basically, x plus 1, quantity raised to the 2/3, quantity raised to the 3/2 is just what? X plus 1. So that went from all those parentheses that you were asking about before, just x plus 1. But on the right side, I have 4 raised to the 3/2. What do you think I could do with that? How?
Turn it into.
I mean, if it was 4 squared, cool. If it was 4 cubed, cool. But it's 4 raised to the 3/2.
Turn it into a.
Turn it into a radical, right? So what would my index be? 2. Do I need to write a 2 if that's the index? No. What's the base of my radicand? With the exponent of 3. Now, on these, I'm going to be taking the positive and the negative square root of 4 to the 3rd power. If my index is even, remember how when we were solving square roots, when we were graphing and a quadratic formula and all that stuff, we do plus or minus. If your index is even, you have to take the positive root and the negative root. If the index is odd, like the 3rd root or 5th root or 7th root, you can't do positive and negative. But if it's even, you can. Okay, so let me show you. There's 2 ways that I could simplify the square root of 4/3. I could either take the square root of 4 first, which is what? The square root of 4 is 2. And then I could cube it. 2 cubed is what? 8. Or I could do 4 cubed first. I haven't taken the square root, so I still have a radical. Anybody remember what 4 cubed is? 4 times 4 times 64. And then take the square root of 64, which is 8. Personally, I like my left side better as long as that base, if I can take the square root of 4, I do. If that was like the square root of 5, well, I can't take the square root of 5. Well, I can with get a decimal, right? But if I can take the square root easily, then I do that, and then I wait to do the exponent. Because sometimes if you do the exponent first, you're going to get a really big number. So up to you, but they both work out the same. So now I have x plus 1 equals positive or negative 8. Me personally, since 8 can be positive, 8 can be negative, I don't want to confuse myself and subtract 1 now. So I make 2 equations, set 1 equal to the positive 8 and set 1 equal to the negative 8, and then just solve them separately. Now I've got 2 solutions here. I want to make sure I don't have anything extraneous, because you just never know. Or make sure I did it right. Because sometimes it may not be extraneous. It may be that you just did it wrong. And you don't know which, really. When I'm checking, again, I can either plug it into the original equation or I can plug it into the part of the equation where I isolated my parentheses. That's what I prefer. So when I check, I'm going to plug it into x plus 1 quantity raised to the 2/3 equals 4. I'm going to check 7 first. So 7 plus 1 is 8 raised to the 2/3. 8 raised to the 2/3, I'm going to write that as a radical. So that'd be the cubed root of 8 squared. We can either do 8 squared is 64 or we can do the cubed root of 8. Can you take the cubed root of 8? Yeah, so I would do that. Cubed root of 8 is 2. My radical's gone. And then 2 squared is 4. Is that true? So we know 7's a solution. Let me check x equals -9. So -9 plus 1, that's -8 in parentheses, the negatives in parentheses. So that's the cubed root of -8 quantity squared. Now this time, just in case you're going to confuse yourself with a negative, you can have a negative under a radical when that index is odd. That's not going to make an imaginary number, okay? But I would probably do -8 quantity squared, which is a positive 64. And what's the cubed root of 64? 4. Square root of 64 is 8, cubed root is 4. So -9 also works. Coolio? Have any questions? Comentarios? Preguntas? How about this? Think we can handle it? Yeah. This one does have a radical in it. The last one didn't. Do what you think you're supposed to do. You know, if you have those parentheses or a radical, we know we got to isolate it. Even if we get stuck after that, we at least know we have to isolate it before we can do anything else. So what do you think? Okay. So I have 3 times the 5th root of x plus 1 quantity cubed equals 24. Divide by 3. So I have the 5th root of x plus 1 quantity cubed equals 8. Can I take the 5th root of x plus 1 quantity cubed? No. What if it was x? What if it was the 5th root of x plus 1 quantity raised to the 5th power? Then it would be what? X plus 1, right? Right now, I have 3 factors of x plus 1. To be able to take the 5th root, I would need 5 factors, right? I only have 3. So, how are we going to get rid of this radical?
By the exponent of 2. Or 5.
How about this? How about we rewrite it in exponential form? Can we do that? Okay, so exponential form, the base would be x plus 1. Those parentheses are going to be important. What would the exponent be? 3/5. Now, I'm not raising the right side to the 3/5. All I did was convert radical form to exponential form currently. You know what I mean? Okay. So now, I'll raise both sides to the reciprocal of 3/5, which is going to be what? So I will raise 8 to the 5/3. Before, I didn't want to raise it to the 3/5 because I was just converting from one form to the other, right? So 3/5 times 5/3, power to a power would be 15/5, which is 1. X plus 1 to the first power is just x plus 1 equals. If that was 8 to the 5th or 8 cubed, I could just do that, right? But it's not. It's a fraction, exponent that's rational. So let's convert it to a radical. What would the index be?
3.
3. Cubed root of 8 to the 5th. Now, would I be taking the positive negative cubed root?
No.
No, because index is odd. If it was even, I would. Now, you could either do the cubed root of 8 first, or you could do 8 to the 5th power first. Now, this is what I was talking about. How if I decided to do 8 to the 5th power first, 32,768. Which is fine. You could do that. But could I take the cube root of 8?
Yeah.
That's just 2, right? And 2 to the 5th power is going to be a whole lot smaller than 8 to the 5th power. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And again, that wasn't a positive or negative, right? Give myself a little more space up here. So if I subtract 1 from both sides, x equals 31. I didn't make 2 separate equations because I didn't have a positive and negative 32, just a positive 32. Now, of course, I'm going to check it because that's what we do as good math students. And I could totally check it from the original, but I got a lot going on there. I could check it from this step here. Personally, I like to check it from the isolated step. That's less work if you ask me, and they mean the same thing. So the 5th root of, instead of x plus 1, that will be 31 plus 1 quantity cubed, and I want to see if that equals 8. So that's the 5th root of 32 cubed. 32 cubed is probably a pretty big number. 32,768. So I could do that, or can I take the 5th root of 32?
Yeah.
What is it? 2, right? We just did it. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So I'll take the 5th root of 32 is 2. And then 2 cubed equals 8. Is that true?
Yes.
So 8's not my solution. 31 is my solution. We good? Page 129, last page, last page. Is this a radical equation? Even though there's no radical? Yeah.
Oh, yeah.
Oh, yeah. What should I do first? Divide by 2, so we get isolate those parentheses, right? So I get x plus 3, quantity raised to the 2/3 equals 4. Now what? Raise both sides by the reciprocal of 2/3, which is 3/2. So yeah, x plus 3 to the 2/3 raised to the 3/2 is x plus 3 equals 4 to the 3/2. I'm going to go ahead and turn that into a radical. So it would be what? Square root of 4 cubed. And since it's square root, it's going to be positive, negative, right? So I'm going to get two answers, possibly. So x plus 3 equals positive, negative. What's the square root of 4? 2. And 2 cubed is 8. Or I could have said 4 cubed is 64 and the square root of 64 is 8. Either way, same thing. I like to make two separate equations since 8 can be positive and it can also be negative. Cool with that? Let me check it real quick. I'm going to check 5 first, and I will plug it into once I divided both sides by 2 and got x plus 3 to the 2/3 equals 4. So that would be 5 plus 3 is 8 to the 2/3, which is the cubed root of 8 squared. Cubed root of 8 is 2. 2 squared is 4. 4 equals 4. True. So 5 is the solution. And now we'll check negative 11. So negative 11 plus 3. Negative 8, quantity raised to the 2/3 equals 4. So that's the cubed root of negative 8 quantity squared. Now in this one I would probably do negative 8 quantity squared first so we don't confuse ourselves. But the cubed root of negative 8 is negative 2. But I'm going to do negative 8 quantity squared first and get a positive 64. And what's the cubed root of 64? The square root of 64 is 8. The cubed root is 4, right? So negative 11, also a solution. One more, and then I'll let you practice. Yes, ma'am.
Do you still do like positive or negative if it's the cube root?
Nope.
Just
If your root or your index is odd, you don't do positive, negative. Because it's not possible. If it's even, because like the square root of 4, 2 times 2 is 4, negative 2 times negative 2 is 4, okay? The cubed root of 8, 2 times 2 times 2 is 8. Negative 2 times negative 2 times negative 2 is negative 8. So when you multiply the same sign together an odd number of times, like if I multiply negative together, do you see what I'm saying? So if your index is even, it's positive, negative. If it's odd, it's just positive, okay? All right, one more. What in the world? Wait, what'd you say to do first? Add 5. So we have 4x raised to the 3/2 equals 108. Okay, so one person said divide by 4. One person said change it to a radical. I have to divide by 4, right? Because what's 4's exponent? 1. If this was in parentheses and the whole thing was being raised to the 3/2, then yeah, we would turn it into radical at this point. But it's not. So that 4 has an exponent of 1. We got to get rid of it. It does not go under the radical. So we have x raised to the 3/2 equals, what is 108 divided by 4? 27. Now what? What do we do? Raise both sides to the reciprocal. So x to the 3/2 raised to the 2/3 is x to the 6/6, which is x to the first, which is x, equals cubed root 27 squared. Is that going to be positive, negative? No, because the index is odd, right? So you can either do 27 squared first and then take the cubed root, or cubed root of 27 and then square it. Can we take the cubed root of 27? Then that's what I would do. What is the cubed root of 27? And then 3 squared is 9. Let me check myself before I wreck myself. I'm going to check here at x raised to the 3/2 equals 27. So that would be 9 raised to the 3/2 equals 27, which is the square root of 9 cubed. Square root of 9 is 3, and 3 cubed does equal 27. So 9 is my solution. Any questions? Comments or concerns? Alrighty then.